My name is Permal Jagan and I'm doing well. Hope you also doing well. And today we are going to learn some malware analysis. And it's gonna be a walkthrough kind of thing. I'm not gonna take a malware analysis challenge. Maybe we will be doing that in a separate stream, in an upcoming stream. But before that, it's essential to understand the basics, the fundamentals of malware analysis. So that is why I thought to choose couple of TryHackMe rooms and solve them. It is not necessarily a challenge, but it is kind of a walkthrough. It's going to teach you some basic theories or some concepts, some tools for the malware analysis. So without further ado, let's start. Now you are seeing the screen. It is a TryHackMe platform. It's a beginner friendly platform, to be honest. The platform that teaches cybersecurity, be it red teaming, be it blue teaming, any kind of thing related to cybersecurity, you can find some source material, some resources from this TryHackMe platform. It is not completely free. There is also a paid part, but as a free user, you can access certain resources. I think as a beginner, it is quite fine to start your learning. Okay, now as I committed, as I mentioned in the stream title, I'm going to do some malware analysis and it's going to be some theory. We are going to strengthen our fundamentals by doing some theory in TryHackMe. So let's go through that. I chose walkthrough part in TryHackMe platform and I did search for the term malware. And now let me do one thing. I will just pick a couple of rooms from this part. So you can see the multiple rooms. In TryHackMe platform, the room is a term for a particular exercise. So there are certain rooms here, but I wish to go with the basic static analysis, then advanced static analysis, followed by a dynamic analysis, basic dynamic analysis, and followed by the advanced dynamic analysis. Well, when you hear the static analysis and dynamic analysis as a beginner, you might not have any idea, but let me tell you briefly. Malware analysis, first of all, is all about assessing an executable. It is not necessarily a exe file. It could be any file that does some command execution, some sort of changes on your operating system. So that kind of files, we call it as an executable. And malware analysis is all about examining an unknown executable file, because if it is doing a nefarious thing, a harmful things, then you cannot execute that directly on your system, right? So that is where the malware analysis part comes in, because it actually helps us to assess the file without executing it or executing it in a controlled environment. And that's where this static and dynamic analysis part comes in. Static analysis is all about assessing a file without executing, without triggering it. And there are certain tools to do that. I will tell you what are all those tools. Then dynamic analysis is all about executing a malware or a file, executable file, in a controlled environment. So when you execute them, you can make sure that infection is not spreading to your host machine or any other adjacent machines. And that's the beauty of the dynamic analysis. There are certain sandbox, or you can build your own sandbox to do dynamic analysis. All right, now without wasting time, let's get into this basic static analysis. So I'll make sure every recording of mine is around 20 minutes. So that is actually the limit. Now let's go and read through this. All right, so it's a basic static analysis and there are some prerequisites. So before we start doing this room, they are advising us to understand the basic malware analysis and some x86 assembly language and the architecture. So they ask us to learn all these things. I already made a couple of videos about x86, so that is fine for now. Now, the learning objective. The lab setup for malware analysis, searching for strings in a malware, fingerprinting malware through hashes, signature based detection mechanisms, extracting useful information from PE header. So I will try to explain what are all these things in a moment, but let's get in. Now let's go and start this lab setup. I guess, yes, we are in a TryHackMe folder now. Let me create a folder for maybe a malware analysis. So inside malware analysis, I create a directory called static. So inside static, I'm gonna put all the static analysis related things. Let me create a tmux session so that I won't be losing my session when I'm closing it accidentally. Okay, if I close it accidentally. Now I need to start this machine because to solve this challenge, we need to start a machine separately. Fine. Now let me go and connect to the VPN of TryHackMe. Come on. THM. I think I don't have that VPN file yet. So what I can do, maybe I'll duplicate this tab. Yes. I will go and download the VPN config. View profile. Where to download this VPN file? Manage account. VM VPN settings. Yes, here. Okay. I think this is the nearest region. This is my region, in fact. So let me start downloading this. I'll create a folder for TryHackMe. And I'm just putting this VPN file in that. Okay, now I have downloaded the VPN file. I'm good to go and start connecting the VPN. Sudo open VPN. TryHackMe EP, that VPN file name. All right, the initialization sequence completed. That means the VPN session established. So let me name this session as OpenVPN. Moving to the next one. When I see the interface details, I could see the IP address is taken, and I'm also showing the IP address here in my TMX. Fine. I connected to this particular room, and you can see the machine IP address. Okay. I also got the machine IP and credentials. Maybe I can use Remina to connect them in RDP. Okay, first of all, before I start doing it, let's go through this lab setup. I exit from the split screen. I just opened it in a separate screen. Okay, before analyzing malware, one must understand that malware is often destructive. This means that when malware is being analyzed, there is a high chance of damaging the environment in which it is being analyzed. This damage can be permanent, and it might take more effort to get rid of the damage than the effort to analyze the malware. So that's the main thing for setting up a lab for the malware analysis challenges. And here is the topic of virtual machine. A lab setup of malware analysis requires the ability to save the state of the machine. Yes, so it is basically an isolated virtual machine, a guest VM of your choice. Then you need to make sure you are having a fresh snapshot of that guest VM, so that whenever you execute a malware inside the guest, once it is done, probably you can revoke it to the fresh state. So that is the necessity of having the snapshot ability in your hypervisor. The machine thus prepared with all the required tools installed. After analyzing malware in the machine, it is restored. Yes, that's what I just mentioned. Virtual machines provide an ideal medium for malware analysis, and you can either use VirtualBox or VMware Workstation. And for the personal use, now the VMware Workstation is available. I'm also using VMware Workstation, and it works quite good for me. These applications can create snapshots. Yes, that's what they say. Created a fresh virtual machine with a new OS install. Set up the machine by installing all the required analysis tools in it. Take a snapshot of the machine. Copy, download malware samples inside the VM. Okay. So here actually they are giving how to set the machine up and take a snapshot, copying the malware into VM, then reverting back to the original state. So all these things. Okay. Now, when you have decided to do a malware analysis or the malware analysis set up, then how you can set up, which VM you can prefer. And TryHackMe also gave a suggestion. You can either use Flare VM or Remnex. I think this is their suggestion. The Flare VM is actually a Windows operating system. The Remnex is actually a Linux operating system based on Linux kernel. Flare VM is a Windows based. Yes, that's what I mentioned. And you can see the GitHub page here. The Flare VM is actually offered by Mandiant. So here you can find their official GitHub page. And also if you scroll down, you will see some installation guide to just spin up the VM, the Flare VM. And moving on, the Remnex. So it's a reverse engineering malware for Linux. So this is also a promising distribution to perform the malware analysis tasks. Okay, now I click the start machine task and the machine will start in a split screen. Okay, that is fine. All right. So we may also log in the machine by using the following information. That means we can use Remina to log in the machine. All right. I will do that. I will do login the machine. But before that, I also give you an advice apart from this setting up the Flare VM and the Remnex VM, because when you install Flare VM or Remnex VM, it's going to install the default set of tools inside the VM. So it's going to take some space, though you are not using it or not. Irrespective of that, it's going to install all the tools present in that package. But if you know you are going to use a limited set of tools, then it is better to spin up a plain Windows VM or Linux VM, then install the required tools alone on the guest VM. And that is the advised stuff by me, because I've been using that kind of things only. We got a command, how many module you will complete, sir? Hi, sir, are you able to do HTTP lab tutorials? Yes, actually, I have done hack the box tutorials as well. In my previous session, I did some hack the box Sherlock solving. Apart from that, apart from this streaming, whenever I get time, I used to solve some hack the box and TryHackMe challenges. Thanks for the comment. Okay, now I'm moving on. Let me connect the VM with Remina. Alt F2 to spin up this. And here is the IP. 10.48.161.149. Accepting the certificate. Username is administrator. Username is administrator. Then password is lemme_in123 exclamation mark. Okay. Now if I enlarge, I'm seeing this resolution is quite small. So I can just fix that by pressing toggle dynamic resolution update. Now it fixed. Now I got into the VM. All right. Now I established the VM. Now let's start with the string search. What is string search? If you take any binary, if you open it in a text editor, you won't be able to understand many of the things present in that file, because they are actually machine friendly language. They are not human readable. But if you carefully look at that binary, there will be some human readable text, some ASCIIs, and how to extract those ASCIIs from the binaries. And that is where the string analysis comes in. So whenever you begin any malware analysis, string analysis is a vital part. It can be done by a simple tool called strings. So let me tell you how string search work. A string search looks at the binary data in the malware sample regardless of its file type, identifies the sequence of ASCII or Unicode characters followed by the null characters. Wherever it finds such sequence, it reports that as a string. So they are actually telling how the string utility functions here. What to look for? Since the analyst has an identity actual strings of interest and differentiate them from the garbage, it is good to know what to look for when performing string search. Although a lot of useful information can be unearthed as string research, the following artifacts can be used at a IOC or prove more useful, because sometimes when you do the string search on a binary, you will be able to uncover some URLs, might be a C2 URL, some IP addresses, or some registry hive details, or some sensitive passwords, credentials, API keys. You might find some interesting information. So that is the importance of doing the string research. And that's what they have mentioned here. The basic string search, how you can do, it's quite simple. The utility is called strings, followed by the binary along with its path. If it is not in the current path. So that is how you should do the string search. Apart from this strings utility, you can use tools like PE Studio. So it is one of the promising static analysis tools available. Here also, if you see and click this strings section, it's gonna list out the strings, and also the beauty of this PE Studio is it's gonna shortlist that particular string based on the blacklisted characters or a phrase, so that you can understand like what kind of file it is, whether it is doing any hazardous things. Then the obfuscated strings. Searching for strings often proves to one of the most effective first steps in malware analysis, as seen in the case of WannaCry. Okay, WannaCry was actually it was a notorious ransomware that was spread across the globe in 2017. So that's what they mentioned. Effective use of string search can often disrupt malware propagation and infection. The malware authors know this and don't want a simple string search to thwart their malware activities. Therefore, they deploy techniques to obfuscate strings in their malware. So when the security researchers trying to find a clue out of the strings, the malware authors often try to thwart that, right? So that is where they do the string obfuscation. So when they did the string obfuscation on a sample, if you try to do the string assessment on the sample, then you won't be able to see any human readable text in that, because they were already obfuscated. So that's the that is all about the obfuscated thing. And malware authors use several techniques to obfuscate the key parts of their code. These techniques often render a string search ineffective. Mandiant, then FireEye launched Floss to solve this problem. Okay, Floss is actually an excellent tool. It is actually launched by Mandiant, who is also the author of Flare VM. So the Floss is actually the tool that is used to uncover or deobfuscate the obfuscated strings. So here actually there is a blog post for this as well. That's what they referred here. Automatically extracting obfuscated strings from malware using using Floss. How are they doing it? They are simply giving Floss followed by the malware name, the executable name. Then it is spitting up all the deobfuscated strings. So the usage looks like the usage is quite simple. So this is the basic usage. If you want to exclude static strings from Floss output, then you can add this particular tag, no static strings. Then -q formatting the output. So here is the usage, the detailed usage of it. Awesome. Cool one to note down. Yes. We can following command to use the flaws to search the obfuscated strings in the binary. No static strings. That means it's going to search only the obfuscated strings. All right. On the desktop VM in the attached, there is a directory named mal with malware samples 126. Use flaws to identify obfuscated strings found in the samples named 256, which these samples contains dbgview.exe. All right. So let's get into this directory. Come on. Yeah. We opened it. There are 6 malware samples. Can I open a PowerShell maybe? I simply press Windows, or no, it won't work. Can I search for PowerShell? Yes. Let me enlarge this. We already crossed the mark, 20-minute mark, but however, I'm just gonna do this. I don't know why it is taking more time. Maybe because of the RDP session slowness. PowerShell. Can I get a quick prompt this time? It is still taking time. How about using command prompt? All right, I got the prompt. Properties, font, 28. Maybe I'm just trying to enlarge this. All right. Now I got into this, and here is the directory. So let me move into the directory. dir. We have the PowerShell session open now. Oh gosh, finally it came. So it's gonna be easy to navigate. Because PowerShell supports the Linux commands. All right. Now okay, it looks okay. There are 6 files here. So what I'm planning to do, I need to use flaws to identify the obfuscated strings on the samples 2, 5, and 6. Okay, so it's quite simple. Do I have flaws? I do have flaws, and the command is no static strings. No static strings, path to binary 256, I guess, right? 2, 5, 6. Look at this. We got some output. That means this sample, the sample 6, is having some obfuscated strings, and it is eventually uncovering them. dbgview.exe. Do I see any executable in that name? Flash decoded strings, decoded 1 strings. Is it still decoding? I guess it is still decoding, but since remaining 2 files didn't give anything. Yeah, look at this. I think it gave the results dbgview.exe. So it was the sample 6. Yeah, correct. Now fingerprinting the malware. Okay, let's try to finish it soon. When analyzing the malware, it is often required to identify unique malware and differentiate them from each other. File names can't be used for this purpose as they can be duplicated easily. They might be confusing also. The file name can also be changing easily. Hence, the hash function is used to identify the malware sample uniquely. Hashing is quite important. It is actually inevitable in malware world. Uh, in malware analysts or the security researchers, they often use malware hashes. Even malware authors try to use malware hashes to identify a particular sample because the hashes won't change. Even if there is a small modification on the malware sample, the hashes will change. And that's what leads all of them, the malware researchers, malware authors, everyone towards hashes. And that's what they say. Hashing functions take the file and data of arbitrary length, and it does some complex mathematics, then create a standard hash with standard length. And the hash is actually constant if the file is constant. If the file is altered, the hash is going to change. And that's the thing, that's the beauty of using hashing. And that's what they mentioned. Besides identifying files, hashes are also used to store passwords and authenticate users. In malware analysis, hash files can be used to identify unique malware. Search for this malware to identify different repository databases and indicators of compromise. All right. And here you can see the commonly used hashing techniques. MD5, SHA1, SHA256. So these are all the common hashing techniques. And in Linux, everyone will be having that utility. If you want to find a hash of a particular file, then you can simply give a command SHA256 sum, then the particular file name to find the hash of a file. Okay, so that is how you should be calculating the hash. Hello, XA, the username. Although a collision, okay, the first two types of hashes are now considered insecure because they are actually lesser in length. That's why they say it is not secure enough, prone to collision attack. Therefore, 256 sum is currently considered the most secure method of calculating the file hash. All right. Finding similar files using hashes. There is another hash type is called imp hash. Let's see what it is. The imp hash stands for import hash. And you can find the imp hash here in the PE Studio. If you click the file name here in this place, you can find the imp hash. Import functions. Imports are functions that an executable file imports from other files or dynamic DLLs. I think this is an advanced stuff. So when I'm opening a malware file on a PE Studio, I will try to explain what is import and all these things. What about Windows? In Windows also, you can calculate the hash value by using the PowerShell utility, get file hash. There is a PowerShell commandlet, get file hash. You can use that utility to calculate the hash of any file on Windows. The imp hash is fine. The imp hash is hash of the function calls libraries that the malware sample imports and orders which these libraries are present in the sample. This helps identifying the samples from the same thread group and performing the similar activity. More details on the impact. Okay. Actually, they tried explaining cert util. I'm not positive. I haven't done that before, but I'm not sure. I haven't done that to calculate the hashes to cert util. I usually use get file hash to calculate the hashes. This helps identify samples from the same thread group performing the imp hash blocks. Okay. So they just mentioned about the imp hash, and here is a beautiful part. If you are starting the malware analysis, then there is a repository, a promising repository that will hold almost every malware sample in the under the sun. So you can see, I'm just exaggerating, but this is actually a promising repository. That's what I meant. The malware bazaar, and that's the repository is known as. And here is the URL bazaar.abuse.ch, and you can start browse for a malware by using its hash, or by using its name, or by using its type, the tags, or from the reporter name or a signature. So it gives you the various searching options. So you can search for a particular sample, you can pick them, and you can start assessing them in a protected sandbox environment. Fuzzy hashes or SSDeep. Another way to identify similar malware is through fuzzy hashes. A fuzzy hash is context triggered piecewise hash. I'm not positive what it is, but this hash is calculated by dividing a file into pieces and calculating the hashes of different pieces. These methods create multiple inputs with similar sequences of bytes, even though the whole file might be different. Okay, I think they are telling about calculating the SSDeep hash. So this is actually an utility to calculate the SSDeep hash. SSDeep is also a hash type, I guess. Let's calculate the hashes of all the samples in the mal directory in the attached VM. So here they actually tried simply to calculate the SSDeep hash of all the samples present in the MAL directory. Then here what they did, finding matching files with SSDeep. They are searching SSDeep -L RD incoming outgoing trash. I guess they are trying to do some string search. Let's see. We can try the other obvious. We have to SSD hashes. We can match these hashes together the family. They help us to identify the files of bulk data. The documentation link provided above the very good examples of use. -D -R operator that runs SSD utility recursively. L operator outputs the relative paths of the files. The result shows the files match each other. The number in the bracket at the end, the percentage matching among these files. So I think this particular number is actually within the bracket is actually denotes the percentage, the matches of the string. I think they are doing some string search here within the directory. Okay. In the samples located in the desktop mal directory in the attached VM, which of the samples has the same imp hash as file 3? To calculate the imp hash, how can I do that? Here they calculated by using the PE Studio. Do I need to load every file in imp hash? So here is a Python program to calculate the imp hash. I think let me take this one. B imp hash .py. I paste this. So we can just give this file as an argument. It's going to give us the imp hash. Come on, Python 3 imp hash. I think I should be giving file name here. Okay, I go to the VM. Do I have any utility to calculate this? Otherwise, start the PE Studio. I load the malware inside the PE Studio. Um, I should go to desktop, mal directory, the sample3. I'm just loading a sample3 first. And here the imp hash is given here. It starts with F397 copy value. So let me add it somewhere. Maybe I'll put it here. Can I paste? Yes. Yeah. Okay. Now, if I go and load the other samples, F397831B, the first sample ends with 2603. Yes, I think the first sample. The first sample is also having the same imp hash. Yeah, that's correct. Using SSDeep utility, what is the percentage match of the above mentioned files? How can I find that? Maybe can I use the same stuff? SSDeep-LRD. Let's see. SSDeep. Do I have the utility first? Yeah, here is the utility. SSDeep. SSDeep.exe. Malware directory. -L-R-D. Okay, I think I need to choose a file name -L-R-D. We need to search for a specific string, right? Is it asking us to search for the same string? What is the percentage match for the above mentioned files? Incoming, outgoing, trash. Okay, let me do it in the same way. Come on. Maybe can I do like this? I think I should not be mentioning. Okay, I should go to mal directory, or I think they did it from desktop. I go here. Come on. I don't understand this part. I need to give one more read. Using the SSD utility, what is the percentage match of the above mentioned files? Because the imp hash is actually matching between 3 and 1, right? So I guess they are let's see. Outgoing corporate espionage our budget.docs matches incoming budget 2007.dog. Personal matches this one. Incoming, outgoing. Oh, come on. I think I should be giving like this. It's my bad. Yeah, like this. Gosh. 3, 1, I guess. 93. Yes. So I was wrong. I should do like this. SSD -L and R for the recursive and D for operator, some D operator, R operator to run the recursively, L operator output leaves the path of the files. Okay, I think 93 is the percentage, because these two files matches 93%. So that is what the concept of SSD assessment. Okay, I just answered it. We solved half of the challenge. At this stage, I almost reached the 40-minute mark. So I'm going to stop this recording. It's going to be a part 1. So I'm going to resume part 2 maybe in another recording. So until then, I'm signing off. Cheers.